the camera clear? Is the screen
Yes.
clears up? Okay.
Completely great. And by the way, would you like me to display the questions on the screen whenever we
Yeah,
get them,
please.
or?
Yes, please
All
go
right.
for it. Whenever this happens and it's part of the context, we can go ahead and answer those. Otherwise, I can leave them to the very end.
All right, then. Dan,
Okay.
we're leaving the stage for you. We're in the
Thank you so
backstage.
much. Appreciate
All right.
it. Thanks. Okay, so thank you all so much for being here today. It's such a pleasure. This is my first time doing actually a session, for my folks and friends in Turkey. So I'm pretty excited about that. Today's session is going to be called Understanding Blockchain Beyond the Fluff and the Nonsense. And it's pretty exciting, to be quite honest. And yeah, let's just go through it. Okay. So we have a lot of ground to cover today. This is going to be like a 1 hour and a half, or probably 1 hour or 2 hours if you guys have questions or things that you want to ask about. So it's pretty thorough. So my name is Ameen Altajer. As I said, you can always contact me at ameenaltajer.com or at Ameen Altajer, which is my handle for both Twitter and Instagram. I'm currently a Google developer expert in machine learning, which is something I'm really, really happy about. But nonetheless, as I said, on the side, I do a lot of work in banking. I do a lot of work in cybersecurity and such. It's pretty exciting for me. I love this field. And also, I'm currently the CEO of INFINITEWARE, which is the business that I started back when I was in university 12 or 13 years ago. And INFINITEWARE is a strictly AI business. We were a game development business, but now we focus completely on machine learning products and services. And even like other AI stuff, even for games, for example. Some of our clients, I don't want to take a lot of your time, so just for reference. Okay, cool. So I'm not sure if this is actually true here, but I just want to know if you guys, like if there's a big part of you guys here today in the audience, people that work in the financial, in the financial industry, basically. But I can probably guess that maybe it's half and half. Maybe you guys have an experience with the financial industry or so, and the other people are, and the rest of the people are actually technical people. So this is going to be very interesting. So I'm going to keep it really, really cool. I'm going to start from the ground up. So in case, you don't have any experience with those terms, you get to have the experience to learn about all of these things from the ground up. Today's agenda is going to be like that. We're going to have a small, brief introduction about the economy and banking 101. Even if you don't like banking, just like myself, at least you get the experience to understand how the system works from the ground up, so you can understand how blockchain and Bitcoin, in this case, really try to somehow, provide an alternative for the system. We're going to be talking about decentralization as well. Like if you go to any entity, any institution, for them, centralization, is all the craze, is the best way to build systems. But we're going to challenge that today, in the second chapter, where we talk about decentralization and if it's really better than centralization. We're also going to be talking about Bitcoin, but the concept of Bitcoin, I mean, we're going to dig deep into how it works, but we're not going to provide a lot of advice, to be quite honest, not really. We're not going to provide any advice on investment and such. I'm not really interested in that in this specific chapter, because I want you to understand how it works on the side, because it is honestly the benchmark for so many blockchains out there, and knowing how Bitcoin works is really crucial for you to pick up some of the new concepts coming in, from other platforms as well. Fourth, we're going to be talking about Ethereum, which is a spinoff that came after Bitcoin, and they tried to do few things different from Bitcoin, which is also a very crucial project if you want to understand how blockchain is all about and how it's shaping the future in a way. We're also going to be talking about notable mentions, a few cool things that I'm really happy about and things that I really admire, and I think they have a lot of potential in the future, a few projects and a few ideas. And then we're going to get to the portion that a lot of people are waiting for. I'm not going to talk about investment, but I'm just going to get you let's say the baseline of how you should think when you get into that field, and how Bitcoin is perceived by investors, basically. Okay, and the people who are getting themselves into the investment aspect of it. So a lot of stuff to cover. Hopefully we'll be able to cover it in 1 hour and a half, or probably 2, but this is going to be an interesting journey for both of us. Okay, so the first thing that I normally ask a lot of my audience, is Bitcoin evil or not? Let's be quite honest. What is your take, guys, when we're talking about Bitcoin? You can probably just say it in the comments, and you can just answer yourselves if you wanted to. But this is the $1,000,000 question that a lot of people go through whenever they hear about Bitcoin. Is it really an evil invention, or is it something totally different? So a lot of people have mixed opinions when it comes to Bitcoin, and I cannot really blame a lot of people for getting different notions about Bitcoin, because it's just like another medium, just like the internet, basically. The internet can be used for good or for bad, or even for the ugly if you think about it. But Bitcoin is also the same thing. Bitcoin, as you're probably going to see like down the line now in the presentation, that it has so many good things and so many bad things depending on the perception that you have, depending on the angle that you see from it. So we'll see that. Now, a little disclaimer before we go on. I don't know everything in life, so don't go crazy on me if I say something wrong. Please just correct me. But to a greater extent, I really understand my way through cryptocurrencies and blockchain, as I've done a lot of commercial projects in that space. But nonetheless, don't go crazy on me. So I'm very open about responding to issues and errors. Okay, so chapter 1. Let's talk about the economy and banking in general. So this is your guide, for economy and banking 101. Are you sure you really understand the system? So back in the day, when humans, like really a long time ago, when they wanted to transact, they did not really have the tools to go and do a lot of, do not have the tools to do transactions and be very explicit about what they want to exchange with other people. So one of the old methods, as you probably know, is the idea of exchange. So you have, let's say, a commodity like a cow or something like that, and then you just exchange it for something else, something that you want from somebody else. Imagine you have, let's say, food, or you have something that you want to use to build your house. So it was just a matter of exchanging stuff in order to get, day by day. And that is not super bad. Nonetheless, let's be honest, it's not the best choice. It's not the best, course of mediums, basically, using that sort of thing, especially when you don't have the fungibility attribute. Now, you might be asking yourself, what do I mean when I say fungibility? Now, that means the currency, or let's say the medium of exchange that we're using in order to do that sort of exchange, cannot be divided. So you cannot, for example, take a cow and split into two halves, and you're going to have two different small cows. This doesn't happen in reality, right? So this means you either have to take the full cow and transact it for something else, something that is worthwhile for you. Otherwise, you won't be able to get into that sort of transaction. So as you can probably tell, not the best, tool out there, but this is what we used to do. Now, this is important because we normally transact based on two things. You either transact your experience or you transact your time. But if you think about it, time and experience, they go hand in hand, which means you might acquire experience when you dedicate a lot of time to something. So honestly, what we're talking about here, when we're selling something, when we're transacting, when we're exchanging stuff, we're basically exchanging things that are worthwhile of our time and experience. And that is really important because the idea behind money is not so bad after all. Now, a lot of people had different ideas when it comes to money. But money as a general tool is not so bad. Money is actually one of the best inventions that we've ever come with as humans. So the idea that I can have a medium that can allow me to transact in this full freedom sort of environment, and I can have that fungibility aspect that we talked about, where you can divide, a specific unit into a smaller unit, so you can, do that transactions. You can do those transactions without really, without really working with big units. That is really amazing, and money allows you to do that. So when we're talking also about money, we cannot forget about the idea of trust. Because when you're transacting, there's a lot of trust involved. So when you give somebody money, you're expecting the merchandise to come also, like in the other, in the complementing the transaction. But what I'm trying to say here, trust is really a crucial aspect of the idea of transacting with money. And so what happened in the past, a lot of people figured out that trust is probably the deal breaker when we're talking about transactions. How can you exactly do transactions or transact with somebody if you don't know if they're going to pay you back, if they're going to give you the merchandise the second they receive the money? So there were a lot of questions surrounding the idea behind money. And so the concept of banks came on board early on to solve that sort of issue. Because with the bank, with the idea of banks, it's pretty straightforward. You give people your money, They save it for you, they protect it for you, and then when you want to transact somehow, because that bank has also the same relationship as yourself with the bank, it has the same sort of scheme with other beneficiaries, in the ecosystem, trying to put their money, trying to, to fairly coordinate and play in the system. With that sort of a scheme, it becomes much easier for people to do trust, because you have this middleman in the middle, and it's middleman, and it's doing a lot of work just to make sure that people are worthwhile, of doing transactions, and you're not going to be basically screwed when you get into that sort of agreement. So this was basically the idea of banks. So to keep it very short, about banks, the idea was pretty simple. We keep your money and we give it to you whenever you want, but however, we take a very small chunk, as a fee for our services. So nothing bad about that at all. However, today, banks have come a long way, yeah? Now they become this crazy beast, and they do all sort of stuff. Things like personal loans, auto loans, mortgage loans, and don't get me started on mortgage loans. In credit cards, oh my God. Credit card deserves a different session on its own because it's so crazy, yeah? And so people just hear about all these things in the financial industry. Is so funny because it calls them financial products, yeah? But in reality, it's just different ways and schemes in order to handle money, to provide people with different services, basically, and different offerings. And so a lot of people don't understand how these work and everything, but this is why banks have acquired a lot of the bad reputation, because not a lot of people understand how these things work. And when you integrate with these systems and you don't know how these things work, you will probably get screwed down the line, yeah? And so loans are really good, and they're not really bad. A lot of people have also very bad ideas on the idea of, loans. But the reality is loans are not really that horrible, but they can be also used for good and bad. A good example is, the idea behind money is when you have money in the bank and you don't have any plans for it and you don't know how to use it, you can also offer it to somebody else, somebody like an entrepreneur, somebody that has a great business idea in order to go for and do something really great with that. So it's not generally that bad, yeah? It depends on the way you see it. So we got a question on how can we use blockchain to content everyday areas such as healthcare and education other than the financial fees? This is the gist of my talk. So I'm trying to explain how everything works, and we're going to talk. And remember, we have 2 hours, a lot of time to kill. And then at the end of it, you'll be able to understand how you can really leverage those use cases after you understand the tech. Because in my humble opinion, a lot of people have different ideas about blockchain, and they don't know how it works, and they base their information and their knowledge on whatever is circulated around in social media. And so when you don't really have that solid foundation in knowing how it works, it is very easy for you to speculate and just, falsify yourself by saying, yes, I can use it here, and I can use it there, and I can use it that. Yeah, but we'll get to that. So, we have other stuff like basically, sharks that are working in the industry, and they do money. They allow people to borrow money, but these money sharks basically have a lot of issues that come with this sort of arrangement. So the idea here is, because the financial system is now getting so complicated, a lot of people introduce the idea of regulations. And the idea behind regulations is you want to establish a sort of ground rules, either operated by the government, operated by a bank, operated by, let's say, a bigger, even a larger regulatory body, like, let's say, the European Union, for example, something like that. And the gist of it is that you want to, avoid crazy and illegal things happening within your nation. So a good example is when you have a government body, let's say in Russia or in Turkey or in Bahrain, and they're trying to make sure that the economy goes well without, doing really bad stuff. So the idea behind regulations is not so bad as well. It's introducing rules to make sure that everyone, play fair, through the system. And it's really good because it's not only that those banks can do something wrong, it's even that, people also, like even engineers, even businessmen can even be crooked. They can even do bad stuff in order to get money. So without that regulation framework working out and, making sure that everyone is protected, you can really just put all of your work, all of your economy to haywire, basically. In supplementing that idea, this is why in each country we have the idea behind central banks. And the promise of central banks is that they're going to regulate your economy 24/7. And so, making sure that there's no money laundering happening in, they're making sure that no bad businesses are doing promises without really, satisfying those promises and delivering on those promises. People don't steal each other's money. No shady business happening in. So the promise of central banking is not so bad, again, just like everything else that we've seen so far. But the $1,000,000 question, is it really what's happening here? Is it really that central banking is doing the right thing, just like what we expect? Or is it diverging just a bit? So just for you to be in the picture and to give you a couple of examples, every country has a central bank when it wants to regulate its economy. So for Bahrain example, for example, we have the Central Bank of Bahrain. We have in Saudi the Saudi Arabian Monetary Authority, aka SAMA, and now they've changed their name to Central Bank of Saudi. We also have the Central Bank of Kuwait. So all of these bodies, the whole purpose of them, just to make sure that everybody within the ecosystem of the economy plays fair. There's no shady business happening in, and there are no, really, really weird stuff happening that can really, jeopardize stuff. Now, I normally put this picture and I ask the audience and I tell them, any idea what this is? You guys know what this is? You can probably try to, guess and put it in the comment section, but let me just tell you directly what this is. So this is what we call the Federal Reserve. The Federal Reserve is actually the central bank of the US. Now, for different political reasons, the Federal Reserve is probably the biggest and the strongest central bank, and it has even rules and has things that it can even influence with other nations. So because everything is connected to the USD nowadays, the USD, which is the US dollar, the Federal Reserve has a lot of power issuing rules, government and governance rules, not only within the US, but also in different places in the world. Now, what is funny for me is that the Federal Reserve is broken down into two words. You've got federal and you've got also reserve, yeah? So the word federal, it should mean that, it is part of the government. But if you look into it and you look into the history of it, the Federal Reserve, to a great extent, is not really that federal. And the Federal Reserve actually has shareholders, which means, you've got people that are benefiting, people who are getting dividends from the system. And you also get this word, which is reserve. And that means that we at least should have a reserve of some sort. We have reserves for gold or so, but in reality, in the Federal Reserve, it's a big question mark. You can do your own research, but those 2 points are crazy when we're talking about the Federal Reserve. And that actually takes us to a great important concept that we have to clear out before we understand the idea behind blockchain, because with Bitcoin and blockchain, there's a lot of misconceptions. A good example is here that a lot of people believe that the US dollar is actually backed by gold. So this is what we call pegged, or basically pegged to gold or backed by gold. And the idea is when you want to print new money, when you want to print new current US dollars, you have to match it with an amount of gold that you have somewhere else in order to have that sort of liquidity to match each other, to match yourself. However, maybe you don't know this, but back in 1971, there's been this thing that got really huge back then. It's called the Nixon Golden Standard. And the idea is the US president back at that time, Nixon, said that, we're no longer going to keep the gold, attached to the US dollar. And this changes a lot of the dynamics now in the relationship especially in the idea of the US dollar. Because that means, you can now print money if you're the US government and you don't have to match it with gold. And that can allow you to go crazy. You can just do crazy inflation. You can do a lot of bad stuff because nobody is going to account for the gold that you have. So there's no standard, there's no protocol basically to do it. And remember, everything that we're talking about here goes basically goes through a lot of history, and there's a lot of politics behind that. And even what's so funny, back in those days, when the USD actually got introduced and it got to be used like a medium, which was neutral among a lot of countries, the rate of all of these currencies were actually fixed to the US dollar. And this is something that not a lot of people understand and know. So when you say, for example, the BHD or the Bahraini dinar, it had a fixed rate against the USD. But now we have the idea of floating rate, and this has a lot of impact. This has a lot of reasons coming in because of the idea behind that separation between gold and the USD. So I just want you to understand how the financial system, the modern financial system, is not so modern after all. Yeah. And so these banks, normally these big banks, they understand the idea behind foreign exchange, the currency exchanges and everything. And so they base their products and services based on this idea, and they make a lot of money. This is why when you go to big banks, you will normally have these big places, these people that, they call themselves traders, which really, which is funny. But the idea is that they try to make business by leveraging the margins, of doing after they do exchanges, between high volume transactions in terms of currencies, and then they make their money from that specific margin. But with a large volume, you can really make a lot of money. Now, the idea that I want to bring here is that the modern financial system is not so modern after all. There's a lot of stuff, and central banking in general the Federal Reserve itself is probably now more than 100 years in terms of age. So it's not so modern after all. And it requires really a hard boot in order to make it really new and, to really just avoid a lot of the mishaps that have happened across the years. One of the issues that have happened, you've probably remembered that if you witnessed it. Back in 2008, the financial crisis was so crazy that a lot of people got, fired from their jobs and everything. And all of that because the financial system is so attached to itself. And get this, banks like Lehman Brothers, banks that tampered with the economy, banks that really gave a lot of loans without doing an imperative process that we call KYC, or know your customer, without really knowing if your customer, the person who's getting the loan, if they don't have the ability to go and pay your loan back, it's not just you as a bank, you're just going to get hurt. The whole chain just expands to every single country. And this is what happened in 2008. In 2008, it was the ultimate testament for everyone else to see in the world that, banking in general is completely flawed. When you have banks, private banks like Lehman Brothers and every one of those, you're trying to monetize as much as possible, but with no regard to the economy, and the regulations are not really working after all, the damage is not only going to be within the nation itself. It's not going to be in the US. I know people in Bahrain that got fired because of this financial crisis, and you probably know a lot of people as well, if you encounter those people and their stories. So the verdict here is the financial system is not so great after all. And what is so funny, just to complement this idea before we close in this chapter, is that the US figured out that some of those banks are just too big to fail. And that means those banks they're going to take down their economy with them if they lose, if they go bankrupt. And so what the US has done is that it started printing more money. And they call this process the quantitative easing, basically. So it's a very fancy name, but what it means is printing more money in order to satisfy that, basically, the amounts that, just to satisfy the issue back then. So it's called quantitative easing. But the problem with printing more money is that you don't really benefit your country. You don't benefit your nation, because that means you've got more money in circulation, less commodities, less goods in circulation. So also people are going to raise their prices as well. So printing money, not so good. Yeah. Okay, so this is basically a very short background about how the financial system works, and how it does its work, and the issues that have happened across the years. Now, this is really a great segue to our discussion today, which is decentralization, which is the second chapter. Now, I hear a lot of people talking about the idea behind centralization. That centralization is the holy grail. Everyone should centralize their systems because it's better and easier, and it helps and makes things simpler for everyone. Yeah, I can really agree with that. I'm not saying otherwise, but there are genuine use cases where centralization would really, really suck. And we're going to get to that in a second. So I normally ask my audience as well, and you can probably talk about that in the comments again. Is it better when everything goes centralized? What's your take? let's just keep a bit of momentum here. Let's just do a bit of momentum in the comment section, to keep things exciting. But yeah, is it really that good? Is centralized good? Let me take you my 2 cents. Let me give you my 2 cents in this subject. First things first. When you make things centralized, even though there are really good benefits and perks of doing this sort of thing, for example, you can have a government system that has every single thing that you want to access, and you just allow people to access that single website and they're good to go. They don't have to look for information across multiple systems, multiple websites, and this happens all the time with nations. If you go to a country and you're trying to get your driver license, it's very crazy that you have to roam around in multiple websites to get to what you want. So centralizing stuff is not really that bad when you think about it from an efficiency point of view. Yeah. So there are genuine use cases. However, when this fails, you get to see it with your own eyes. So a good example is the idea behind security and privacy. Now, we've seen a lot of cool sessions about cybersecurity today, right? And if there's one thing that you've witnessed today is that security is really bad when it's centralized. When you have a single host that has your passwords, when you have a single account that people can attack and target, it's just gonna be like more of a, it's gonna be a very clear target for hackers to just jump in and try to break your system and get to what they want, whether it's data, encryption keys, whatever it is. So security and privacy is not so good with the idea behind, with the idea of centralization, because it's very clear for hackers, or in terms of what they have to attack. The second point is it's a power control and a sanction game, to be quite honest. Now, if you look into it, no matter what your views are when we're talking about politics and everything else, I'm not interested in talking about politics, but what I want to tell you about is it's a power control game, which means when a country becomes so powerful, it can somehow, emit those rules and really pressurize other countries to not really transact with other countries and do other stuff with them. So this is the idea behind sanctions and power. And you can see a lot of examples with that, correct? The last thing is, even from a redundancy point of view, when you have things centralized, if you don't have an elegant, redundancy system such as clustering and, basically high availability and all of these things, people who are working with the cloud, a single point of failure is going to be, this is exactly the thing that is going to bring down your system and your service. So you have a lot of really, bad stuff that happen with centralization, and you can fix them to a greater extent depending on the methodologies that you use. But the concept itself of centralization might not be the best bet for every problem that we have. Now, that even happens on a bank level. So in case you did not know, every bank has a specific system that they call a core banking system. And this core banking system has the sole job of keeping credit and debit for every account that they have, for every transaction that happens in their books. And they call it a ledger, in case you heard the word ledger. And ledger is going to become very apparent when we talk about blockchain, because Bitcoin and blockchain borrow a lot of those terminologies basically. So the ledger is basically the history, the specific table or book that's just explicitly tells the user of the transaction that we have in their details. So if you go to the bank, there's very likely that they're going to have a core banking system that has the details of the accounting of every account that they have. And this is really important. Now, this core banking system also allows us to go back to the idea of centralization, which means everything is centralized into this box, into this core banking system. So everything that we talked about the pros and cons about centralization also can be reflected in here. So if you have an IT personnel that are not really that qualified, they can really take down the core banking system by mistake, and every service is going to be down. If you have other people that are targeting the core banking, they can just steal everything from that specific box. And let me break it to you, this happens in real life, and we've seen a lot of cases like that. And this goes back to the idea of having the core banking system, or the ledger in this case, in a centralized format. Yeah. And this even happens on a commercial level. We're not talking about data as well. So the financial system itself allows you to send money across the world through specific mediums. You cannot do peer-to-peer transactions. So which means if I want to send money to somebody in Turkey, I can't just give them money. I can either give them cash, which is very difficult to transport. Or I can go one of the formal methods of sending money, such as, remittance services, or I can use Swift, for example. And all of these methods have their pros and cons. Notably cons, you have very slow time to send the money, and you also have some of your money being taken, as a chunk from those providers as well, those connectors and payment processors. So you normally feel as somebody within the system, within this ecosystem, that you're somehow struggling to really, let's say, maximize the potential of the transactions that you want to do. Because when you want to send up money abroad, people are going to take part of your money. When you want to send people money in terms of cash, when you meet with them, it becomes much harder to do it in person. So that sort of control and centralization also happens on a commercial level. It's not only within data and systems. And let me just take you through the international level here. You will probably know this by now, but the US also has a lot of sanctions that it pressurizes other countries through. Russia, Iran, Iraq, as far as I know, if I'm not mistaken. But this is a very cool map to show you how the influence of the US happens, across the board when it comes to allowing people to do, to allow countries in terms of to transact with other countries and such. So to have that power also, that centralization thing happens even on an international level, because everyone needs to transact with the US in a way through the USD. So we have a great idea here that you probably remember from from the old days. We have the idea of torrents. So if you want to get files, you'll probably get torrents through the peer-to-peer system. Yeah, you can download files, you can download music, movies, be it legal or not legal, but the medium is there. The peer-to-peer model allows you to go ahead and get data through a different fashion. So it's not like you have to connect to a centralized server to download a page. It's not like you have to go to google.com and download a page. With the torrent mindset, everyone is a server and everyone also is a client, which means if you need something and you don't find it within, let's say users, if you don't find it within the machine number one, you can also talk to machine number two, and you will have a great chance of finding the file there or the data that you want. So this is the good old peer-to-peer system, which has been working for a very long time, and it's a great system. We love it, and everyone loves it. And so the peer-to-peer system also has pros and cons as well. So with Torrent, for example, with the BitTorrent system, or Torrent to be more accurate, you normally have what we call a tracker. And the name tells you exactly what it's doing. It's tracking everyone, the participants of the system. So when you try to download a file, that system is going to just take you and tell you that, hey, I have all of these people, lining up here, and you can talk to them if you want to download a file or so. So it's not so decentralized, to the full extent, but it does a great job of making things, less centralized, let's say. Now, the holy grail is to keep everyone in a decentralized system, which means there's no dependency on a middleman. And this is the thing that, blockchain really excels in, and we're going to talk about it. So if you think about it as a principle, decentralization is all about controlling the system and giving, it's all about controlling the system by the people. I mean, it's like you don't have a middleman, you don't have a single entity controlling the whole system on its own. You want to distribute power, and you want to have that power to everyone else in the system. So this is the idea behind decentralization. Let's get into Bitcoin so we can see things in action and understand how we can really apply and how everything got really applied within the space. Okay, so first things first. Now, Bitcoin is a decentralized cryptocurrency. And that can mean a lot of things, right? Well, let me break it down bit by bit. It somehow uses a lot of the fundamentals within peer-to-peer, and it does that to do basically a transaction medium in it to allow people to transact in a financial system. But the idea is you don't go through a middleman, and this is really the key takeaway here, which means if you want to send money from one place to another, you don't have to go through a lot of people in order to send the money. Not one person is going to take your money when you send it. You can do what we call a peer-to-peer transaction. Peer-to-peer transacting. So if I want to send to Muhammad, I can send to Muhammad directly the money. without going through chains or middlemen, which is the great thing about it. Now, what's so cool about Bitcoin is that the decentralization that is happening under Bitcoin is using a lot of the cryptography principles out there. And it does that really, really well. And it's fair to say that this is not the first attempt to create a decentralized currency. There were a lot of things before Bitcoin. But Bitcoin really stood out because it has a lot of great features, and we're going to get to that in a second. So just remember, it's a decentralized cryptocurrency. It leverages a lot from the peer-to-peer transacting schemes, and it is completely dependent on cryptography, in order to do that sort of thing and for it to function. Now, a bit of history. So it got started around 2009. What is so funny, it got started as, basically as the aftermath or whatever happened in 2008, the financial crisis that we talked about. And that was really crucial because a lot of people lost faith in the financial system. And so Satoshi Nakamoto, which is a pseudonym basically, so it's not a real name for somebody that we still don't know, created that project back at that time and tried to make it as an alternative for the financial system, the modern one. And the key takeaways behind the system was, and the key goals, is that he wanted to make it, he or she or they, I don't know really honestly, but they wanted to make a system that is completely decentralized, free of middlemen, no middlemen whatsoever, and all the source code should be open source, which means you can also scrutinize the code base if you think that something is fishy. Now, this is really interesting because if you go to banks, and I can tell you from experience, sometimes the IT folks don't really know what they're doing, most of the times, at least in my experience. That means they can really screw up some of the systems that they have, and they can fix it on their own without telling you. So you, as a user, you wouldn't really have much details. You're not going to have much details when it comes to understanding if there's a fault in the system, or if there's something worth fixing. You can't really tell because they keep the code, they keep the systems and everything. Now, with Bitcoin, the dynamics really change because the code is open source, and that is not only for the implementation itself, but even for protocols, for the agreements, everything is actually open source. So it's a much more democratized, let's say, environment for people to, establish a system. And it was the first currency to solve the double spending problem, which essentially means if you want to send something, okay, let's take it from this angle. If you have something physical like a phone and you give it to somebody else, because of the physical world, the second you hand it over to the other person, it goes away from your hand. So you no longer have access to that physical asset. Now, how can you exactly take that principle and do it on blockchain? And sorry, how can you exactly do it in the digital world? Especially the digital world is like, in the digital world, everything is a copy. You send something, you have a copy. You download something, you get a copy. So to have that sort of ownership feel for digital assets, the Bitcoin project really managed to do that sort of fix for the double spending problem, basically. But we can go into greater details down the line. Now, in case you did not know, the Bitcoin code is actually hosted on GitHub, and there it is. And it is so cool. It is actually based on C++. It is so easy to read the code if you have solid principles spanning cryptography and building, let's say, systems that are architected in multiple layers. But it's something that you can probably read within 6 or 7 days. Big parts of the Bitcoin source code, which is really wonderful. Now, with Bitcoin, we have this concept of Bitcoin improvement proposals. And the idea is every time you want to do something within the Bitcoin system, you first propose it, and then people, as we said, collaboratively think about this addition. Is it good? Is it bad? And this is the essence of the open source philosophy, just like with the Linux system, basically. If you have a great thing, we add it, we discuss it before we add it. And the same thing happens within Bitcoin. So even this financial system that we have in here is much more democratized, when we're talking against other systems like the financial system, the modern financial system. Yeah. And these BIPs are actually hosted as well on the Bitcoin, GitHub there, and you can see them. And every one of those items is actually severely documented. So you can see the purpose and what people have done, how they're doing it from a technical perspective. So when all these things are managed, you go ahead and you implement it in the system. So it's a much more organized exercise, to democratize the financial system in a way. Now with Bitcoin, you might ask yourself, this is really weird. How can we really do a system? How can we build a system that can allow us to send money across the world to every participant in the system without having a middleman? How can that really happen? It's difficult because normally we would need a centralized ledger, just like with banks, where people can organize and send money to the bank, and then the bank itself is going to coordinate across the world, with other participants, because the ledger is the golden source for basically the truth. Yeah. But the answer to that is, how about if we all share the ledger? And this is the essence of Bitcoin. Now, when you download Bitcoin, there are multiple versions depending on your goals. But if you download what we call Bitcoin Core, or the standard edition of Bitcoin, which downloads a lot of data, and you probably remember that, if you hear people saying we're running a node in Bitcoin, we're running a Bitcoin Core node, what they're saying essentially is that they downloaded the Bitcoin client itself, and Bitcoin, for it to sync across the world, it has to download the full ledger, ledger that contains all the transactions that have happened in the Bitcoin space from the beginning of time, from the time that Bitcoin started, got incepted, all the way to now. And this is what we call the blockchain, the ledger of the blockchain. And this is becoming bigger, with time. And I remember when it was 300 gigabytes worth of data, and it's growing so large. So the idea is you want to keep as less as possible, the minimum amount of data on the blockchain, because it makes, people getting on board is a very difficult exercise. It becomes extremely difficult to get people on board to download the Bitcoin node core, because you have to sync with the other systems to stay online. But essentially you're going to have the full ledger at your hands. You can verify the transactions on your own. You as a user, you can do all of that work on your own without depending on other players in the system, which is really, really great. So this is the idea behind Bitcoin, is that you copy the full ledger to yourself and you do not trust anybody else. Then you do the bulk of the validation and the verification on your own. And so the question is, okay, how do we get into the Bitcoin network? How do we start getting Bitcoin, this curse that you're talking about? Who are the main participants in the system? And in general, you have users, just like what I said in the beginning. Okay, if you want to participate and run Bitcoin and make it much more, let's say, resilient, you can download the full Bitcoin node core. But however, if you're a regular user, you might not need to go for the full thing. You can just download a mobile app, and the mobile app is a very small version. It does the verification with multiple parties, but it doesn't have the ledger. So when you download the mobile app, you're not really downloading 400 gigabytes worth of data in order to do that work. Yeah. And also, you're going to keep your money in what we call wallets. So wallets is a great change from the idea of basically accounts or bank accounts. We're going to see the differences in a second also. And you also have the idea of exchanges. Now, if you want to travel, you have this idea of exchanges. You go there, you give them your fiat currency, you give them your USD, and you tell them, I need to have, for example, Bahraini dinar, in order to transact in Bahrain if I go into the economy of Bahrain. So anyway, it's like the gateway to another economy, the idea of exchanges. And this also happens to be a reality even on the Bitcoin environment and the Bitcoin system. You have exchanges, specific websites that you can buy, Bitcoins with, and they can send you the money on your wallets, depending on how much money you send, and they can take a small portion of it. But we also have a crucial aspect that not a lot of people understand, that goes by the title of mining or miners. So with miners, you can, and I heard a lot of rumors, but the misconception that I hear all the time is that you can make money free of charge with mining. And that is not really true. And we're going to see that also in this session today. But I just want to point out that these are the most crucial, elements of a Bitcoin system, basically. Now, a good example of some of the biggest, cryptocurrency exchanges, you've got Coinbase, and you got people like Binance, and they don't need any introduction, to be quite honest, because they're pretty popular and everyone knows them. In the Middle East, however, we have Rain, which is a cryptocurrency exchange in Bahrain. They're really based in Bahrain, but they're originally a Saudi company. And we're going to get also to the government aspects, but just remember, it's so funny that a Saudi company started in Bahrain. There must be something out there that did not really allow them to function in Saudi. We're going to get to that. But just remember that we have global exchanges and we also have regional exchanges. Now, the idea behind Bitcoin is the following. If you go to a bank and you tell them, I want to open an account, they will normally ask you to get a lot of information. They will ask you to get them a lot of information about yourself. Your work history, your physical address, everything about yourself, about your identity, in order for them to tell that, okay, this person is legit. We can allow them to create an account and allow them to transact with this financial system that we created. However, with Bitcoin, there's no concept of account. There's this concept of wallet. And what's so funny about the wallet, because it uses a cryptography, it uses the power of cryptography and the stochastic field. You can basically even create wallets without having a lot of internet connection. And this can sometimes really screw up people's minds, because how can I create a wallet, something that is shared with a lot of people, but without having an internet connection? And that goes all the way back to the crypto aspect of it, the cryptography aspect, and we're going to get to that. Yeah, but with Bitcoin, you don't have to go and have a physical address. Your identity as a whole doesn't have to be, doesn't have to go hand in hand with your wallet. And that can be good and bad if you think about it, to be quite honest. You see, if you do something wrong and you have a bank account, it's so easy for the government to track you down and understand that, okay, these are the activities of that person X, and this is the bank account where the money, stays. Okay, and that bank account belongs to that person. And this is more of a recursive thing, so you can follow it all the way, to the right source. But with Bitcoin, it is much more difficult to do that, because when you create a wallet, you don't have to supply your name, your address, and all of that, and it becomes difficult for people to appreciate it, to understand who you are. This is why you get to hear a lot of bad stuff happening on the Bitcoin. Like when cybersecurity issues happen, ransomware breaking into companies and such, normally those hackers try to get money in terms of Bitcoin because it's much more difficult to track. We're not saying it's 100% impossible to track. It is difficult to track. It's just that. And the funny thing about Bitcoin is that when Satoshi Nakamoto started, he made the money, the money in circulation, the Bitcoins basically out there, he made them finite, which means this is different from what we have in the financial system. You see, in the financial system, a government body like the central bank has the power to, push more money into the ecosystem or revoke more money from the ecosystem, depending on the situation. So if you want to allow people to transact, you want them to really do, let's say, more work with their money, you normally want to inject more money into the economy so people can start, making good utility of their money. Otherwise, it's going to be, the inflation is just going to kill it, and they're not going to do a great deal. Yeah. And at the same time, when there's a lot of money around, sometimes the government, or the regulator in this case, would take the money out of the economy to make it more scarce for people to transact, to keep things under control. And this has a lot of, correlation with the idea of employment, and, regulatory work is not so easy, to be quite honest. Now, one thing a lot of people don't understand about Bitcoin is that you own your keys, which means when you create your wallet, you create an encryption key. So there's this concept of private and public keys. You probably heard about them in the earlier sessions about, for cybersecurity. But the idea is you manage your credentials, you manage your own keys. Those funds are gone forever when you lose your keys. So if you have a wallet and that wallet is stored as a file on your machine or as a physical token, if something bad happens to that token, be it a file or hardware equipment, your money is going to be inaccessible to you. You can't just go to a bank and you tell them, please print me another token. This doesn't happen. This is one of the really bad things that are happening within the space. But again, you pay the price for your sovereignty. You pay the price for having the ultimate power over your wallets, over your money. Nobody's going to have the power to freeze your account, to take your money basically under the, under government rules. And also stealing becomes very targeted. And now this is funny personally for me, because a lot of people talk about Bitcoin as if it is not really that secure. When in reality, Bitcoin is extremely secure. But the way people transact on Bitcoin is, what's giving a lot of bad rap to Bitcoin. For example, if you have your home keys and you take your keys and you put them outside of your house, and then you go outside and you come back and your house is completely, empty and there's nothing left in it, would you blame the system or would you blame your stupidity for doing so? It's very obvious that you're going to blame yourself because you did not manage the keys well. And this is what happened with Bitcoin across the time. When you buy Bitcoin and some of those services allow you to, manage your wallet on their services, on their cloud services, you're basically giving them the power to manage your keys, on your behalf. And this is not always good. So there are other services where you can, for example, manage the keys on your own, and they can just send it to your wallet. So they don't have an integrated wallet within their service. So sealing is just a matter of how you use the system. The system is not really that faulty. It's just how people use it, to be quite honest. And one other thing in Bitcoin, there's this concept of interest, but you can never compare it to the idea of interest. But interest, is it really good enough? We're going to see in a second. So in general, Bitcoin allows you to do anonymous transactions, which is sometimes really beautiful because if you want to send money across the world to other countries, you don't have to wear your group identity hat, and you don't have to belong to a specific country in order to send the money. Imagine you have other family members in other countries, and it could be that one of those countries is a sanctioned country. So how would you go about sending them money? Now with Bitcoin, this happens because it's not regulated and you can do it in an anonymous field. Now the non-regulated aspect can go a long mile. Some countries figured out that sending money through Bitcoin might not be the best choice for their economy because sometimes people will just rely on Bitcoin instead of transacting within the economy itself and using their fiat currency of the country, like the native currency of the country. And so many of the countries out there block the idea of Bitcoin. They said, it's not regulated. You're not allowed to transact with it. Some countries, they don't really care about it that much. So they said, transact however you want. We don't really care. In some countries, right in the middle, they figured out that they can strike a balance somehow of saying, we're not going to regulate it, but we're going to give you like warnings of, okay, so try not to do some shady stuff with it. Otherwise, it can bite you in the back. In some other countries, just like in Bahrain, they try to regulate portions of it because they do acknowledge that they can never say no to Bitcoin because the nature of the decentralization and Bitcoin doesn't allow them to block it 100%. But nonetheless, they want to have an official mediums, an official means for other people to get into the system and transact whenever they want. Yeah. And all in all, Bitcoin transactions are very slow because of the nature of the system where you have to send, basically this details across the network. Everyone else has to sync with the network. When you have like hundreds and thousands of nodes out there that are powering this Bitcoin environment, they all need to keep their ledgers updated. And this process takes a lot of time. This is why when you send money across Bitcoin, it's very okay for the system and people to wait for 30 minutes or more, depending on how much you pay to get this transaction verified, in the ledger of so many people out there. So it's slower than traditional mediums. And this is one of the really big points that a lot of people in the financial system, are happy about. When they say Visa, for example, as a payment processor, can process 5,000 transactions per second, where you have on Bitcoin, you can verify 5 or 6 per second, which is not much, to be quite honest. So a bit of comparison here. So the address below is what we call the IBAN address, and this is what you require when you want to send money across the world. So even from this IBAN address, you can really tell a lot of stuff. For example, you can tell the country of the account. The IBAN address, this is the bank address here, bank account address, has the country, it has the bank you're sending to, it has the account itself, and so many details that you can basically deduct from the IBAN address itself. Now, when you go to the Bitcoin address, because we're using a mixture of crypto stuff happening in here, nobody can really tell who owns this address, who owns it, the country that this account resides in. You can't really tell that much. So the Bitcoin address is made in a way to somehow, if you ever studied cybersecurity, you will probably understand this concept of PKI or PKC, which is public key cryptography. Now, I don't want to really explain it that well, but just remember, you've got a regular, so we have what we call symmetric key encryption, where you have you have a password used for both encryption of data and the decryption of data. But we have another scheme that we call PKI, public key infrastructure, where you have two distinct different keys, one for encryption and one for decryption. And there's a lot of use cases that we can build on top of this principle of PKI or PKC. And that principle is being used to a great extent within Bitcoin. And also the idea behind hashing. You remember the idea of hashing or taking signatures of data. Those two things, the integrity using hashing or the digest basically, and public key infrastructure, are the core elements that allow us to go ahead and really make sure that we transact safely on the Bitcoin environments. So this is a sample transaction normally. Imagine I want to say, Ameen is sending Ali one Bitcoin. This is an example transaction, yeah? And so with the use case of public key or cryptography, the idea is the following. When you create a wallet, you basically create a key pair. So you have a private key and a public key. And I'm trying to make it very easy here, very simple, but it can go, to a great length if you wanted to, honestly. It's not as easy as I'm explaining it in here, but this is the general idea. So when you create a wallet, you have two things. You have a public key and a private key. And there is, the public key is almost like your target address for your wallet, basically, when you want to send money to somebody else, or when you want to receive money in this case. Your private key is what you use in order to access those funds. So when you want to send money, your private key is being used in order to sign messages or transactions going to the rest of the people out there to verify to them that, hey, I am Ameen and I'm sending the message because I can sign it with my private address, with my private key, sorry. So this PKI is used in that fashion. And every time you want to use a digital signature of some sort, you have to rely on the idea of digest or hashing algorithms. And remember, with hashing algorithms, the big aspect is you can never reverse those hash results. So if I take, let's say, a transaction and I get a signature of it, there's no way in hell that I can reverse it. I can try to brute force it, just like what happens in the real world, but you can never reverse it. It's not an easy basically process. And those two key elements are extensively being used in the crypto world, especially in Bitcoin under the hood. One great thing about Bitcoin is that it can even create crazy practical use cases. So a lot of people think that, when you send money, it's just a matter of giving people a target address, sending it, and that's it. No, you can actually build very complicated use cases. A good example is this escrow agreement. So imagine you have multiple people, imagine you have a company and you want multiple people to be, the signatories, basically the proxies that can sign a transaction for the money to be transferred somewhere else. This sort of use case can also happen within the Bitcoin environment. You can allow people to have multiple keys and they all have to sign it at the same time, to basically sign this in transaction for the transaction to happen in the first place. So it's not only one person controlling the funds. You can have multiple transactions, multiple people or parties, controlling how the funds are being transferred. And this is really a great deal. And this happens because within Bitcoin, there's a language that we call script, and it's a scripting language within Bitcoin itself that does all of this magic work, in order to verify the signatories, the proxies, and everything else. So there's a lot that happens under the hood. It's not just sending money, that's it. Every time you send money, and when people verify it, they have to execute a program or script embedded within the transaction itself to verify if you can meet, those standards in order for the money to go through. Okay, so this is a very important aspect that I want to dig deep into so you understand and appreciate the power of mining, how mining works, and why it is exactly important for the whole process. So imagine I want to send money. Ameen wants to send money to Better, and your transaction is basically the following. Ameen is sending Better 1 Bitcoin. This is the transaction. So you will normally have a signature that you will embed with that transaction. Now the signature comes in because when I send the money, I have the private key and I have the public key, right? Just like how we simplified it early on. So Ameen, in this case myself, I will verify my signature, I will verify the transaction by putting my signature below, which is a calculation of my private key, which is a digital signature essentially. Now, what happens across the board is that when you and other people, would normally send a lot of transactions. So it's not only you in the Bitcoin environment. A lot of people are sending money as well. So we have this concept of blocks. We have people that are trying to make money from the Bitcoin system, yeah? And people are called miners. What they essentially do is they listen for transactions coming into them, and then they have these blocks. Think about blocks as if they were folders. You save a lot of transactions inside, and then when that block that has a specific size in megabytes, when it gets to that target size, you can treat it as a full block, meaning you can go ahead and you can start doing a lot of stuff going forward. So just think about it as a folder where you keep a volume of transactions so you can do a validation going forward. So what happens is, and the miners, the people who are supposedly making money, what they're essentially doing is, because they have a big folder, a big block that has a lot of transactions, their job is to go through that block and to verify every single transaction. Now you might ask yourself, how can that really happen? Remember when we said every Bitcoin node has the full ledger? It means it has the full access to all the accounts. It can see how much you got in your wallet, how much you own, other people. You can basically see the full breakdown of the transaction. So you can calculate everything on your own. You don't need to delegate that trust to somebody else. And so when somebody says, I want to send, for example, 100 Bitcoin from my account to somebody else, you can really check on your own if that person owns 100 Bitcoins in the first place. You can do that validation without asking anybody else. It's a decentralized operation. This is the beauty of it. So there's a lot of verifications that happens under the hood to make sure that this works. And so miners come in and they use this because it's not just they're doing it for fun. They do it because they're gonna monetize. And let me explain to you how that happens. The Bitcoin system was written in a way that every time you verify a block and you consider it as the winning block that has multiple transactions, so all of these transactions are gonna be settled, but when you verify that block, you're going to have what we call a reward. Now, this reward is called Coinbase, just like the name of the exchange. But Coinbase, the name Coinbase means you have a reward that you can use, which is basically an amount of Bitcoin that you can get basically for yourself if you verify it before the other miners. This is why a lot of miners are fighting through hell, in order to, as fast as possible, verify those transactions and those blocks. So the essence of the verifications happen not only by making sure that every transaction can hold and you have sufficient funds to do the transaction as such. There's a ground rule list basically that you have to go through in order to make sure that this block can really be verified. But the notable thing inside, the thing that is extremely popular, is what we call the nows. So each block has a specific element. So imagine I'm trying to, verify the second block, and every Bitcoin network, every Bitcoin node agree that this is settled, that this is confirmed. When you move to the second one and everyone is trying to race to verify this block, one thing from the older block comes in and it becomes part of this, verification. And this is actually the hash of the block behind. So the idea is, without getting into the technicalities of it here, if you feel that this is too much, is that there's a sort of dependency between the blocks themselves. You can never verify the second block without making sure that the first block is verified. And this builds a dependency graph or a chain, hence the idea of blockchain, in order to make sure that these transactions are verified. So the idea is you have a specific number that you're trying to guess. So believe it or not, this is actually a brute force problem, which makes it much more difficult to solve. This is why people in this blockchain space, or specifically the Bitcoin space, they need a lot of computational power because they're essentially just trying to brute force as much as possible in order to get to that specific secretive number that we call the nonce. And when you find it, it's so easy for you to verify it with other people because You just hash it when you want to verify it, but you can never, figure out that number on your own. It's not a formula. You have to do, basically the work of brute force. And the problem is this now changes across time. So it can have a bigger range, it can have a smaller range, depending on the people who are participating in this mining exercise. So the difficulty, as we'd like to call it, changes dynamically as part of the system. And so when you have a bigger range, imagine I tell you, I want you to find a number between 1 and 1 billion, for example. How many times are you going to take before you get to that number? There's a huge chance that you're going to try to break brute force until you get to that number, especially if I don't give you any things or any hints to start with. And this is the essence of mining. A bunch of people trying to figure out as much as possible and as fast as possible to get to that specific secret number, random number, in order to claim their reward. And so when you get to that number, as we said, it's extremely easy to take that number and send it to the other miners so they can all agree that, yes, you actually won, and you figured out the right secret number for that specific block. Hence, you verified it, and so you earned, you get to earn that block, that coin-based reward, that gets you the money, basically. So this is the essence of the idea behind mining. Now, what's funny is, back in the day when Bitcoin was a small network, maybe that was a feasible choice where you can go in all in on your own and try to figure out and do that brute force on your own or to figure out the number. The problem is now, because we have so many participants in contenders in the Bitcoin ecosystem, it is very difficult to win, especially if you have a lousy laptop like myself. It's very difficult for you to win if you can't do that brute force very, very fast, especially if the range is really huge where you have to find that secret number in order to claim the reward. And so we have this idea of pools where you have a group of people working as a group, and the amount of computation that they dedicate to this network, gives them the money that they earn. So this is what we call hashing power. So imagine you come in with a small laptop, you join in a pool on the Bitcoin ecosystem, and you try to help them with the brute force. When somebody figures out the number, like part of your pool, they're going to share that prize or that reward in a fair way, depending on how much you contributed to that calculation, to that specific search. So this is why pool is a great way to make money if you have lousy hardware. Yeah. And this is something that is now extremely imperative if you want to make money. You can't just compete on your own, especially that Bitcoin has become so big lately that there's a lot of people trying to fight their way and make money through mining. And now this really brings a very cool trivia. This is now this is why you probably know why a lot of people got crazy about owning graphics cards for games, even though they're not doing any games, they're not playing games, they're just getting them because with things like CUDA, with basically that sort of framework and platform, you can now execute specific computation on the graphics card without utilizing the CPU. So dedicating that computation, that computational work that we have to do on the CPU can now be done on the GPU. So there was a lot of work happening in the mining space that targets, NVIDIA's cards basically to do that thing. And then what has happened is that people figured out, we can now probably start investing in specific specialized hardware, in order to just do mining. And this is where ASICs come in. The idea behind ASIC, which is application-specific integrated circuits, come into the picture because now people have different tools, different hardware devices that are solely focused on mining on own. So this piece here that you find has only one purpose, which is to try to help out people in order to figure out the, basically the secret number. And this is why a lot of people have huge places, of just ASICs lying down, trying to figure out the right number to make money. Now, just like what we said, if you remember, we have blocks and they have transactions. Now, it turned out that the first block in the Bitcoin network is called the Genesis block, and this is the root of truth. So when you download your Bitcoin node, when you download it the first time, you actually have the Bitcoin block number 0 embedded within the source code, and it's actually on GitHub if you want to see it. It's part of the code itself, which means you can now verify every single block that comes in on your own without, trusting somebody else, because you have everything within the code itself from the beginning. Yeah. Okay. Let me just check. Do you guys want to have a break, or do you want to continue? If you like the pace, we can continue. I think we're going to finish in less than half an hour. But if you guys want to have a break, just let me know in the comments, just to make sure that we're good. Just let me know in the comments, so we know if you guys want to continue, or keep the momentum here and finish on time. I'm very fine actually with the idea of having a break for 2 minutes. Okay, cool. Let's take a break. Let's get back in 2 minutes. Okay? See you in 2 minutes.
Okay, after 2 minutes, see you again. Thank you very much.
Oğlum dur.
Yok. Alalım.
Şimdi sorabiliriz. Ha tamam o zaman.
Hey, hello again. Mr. Amin, it was amazing, and you have covered from scratch this technology. It was amazing. And
Exactly, yeah. Like
your energy is great. And at that time, if you have any questions, maybe we can take some questions and show the questions on the screen. And after that, by the way, how many times do we have? 30 minutes, right?
Yeah, we have 30 minutes to go. I think we can cover the whole thing. Maybe in 15 minutes we'll finish, and we'll have 15 minutes for questions. If you guys want to keep it 10 minutes, it's up to you.
All right. Then meanwhile, let me also mention that, guys, the first form has been actually sent to the link in the chat. So make sure to finish that. And after that, we're going to be sending the second form link in a bit. So just make sure that don't miss the forms. And see you then in 50 minutes then, I guess, about at the Q&A session.
Okay, cool. So let me just continue then and keep it.
All right.
Yeah. All right. Thanks, guys. Okay, cool. Yeah. So this is basically Genesis of block, just like what we talked. The first specific block within the code, it's hard coded in the code, so you can never go wrong. You can always validate it if there's something is fishy. And this builds all the way to getting all the blocks happening and coming forward in the chain, and you can verify everything on your own if you have the full chain, the full ledger on your own. Okay, cool. So this is why we call it the blockchain, basically, because it is a chain of blocks. Every block has a dependency that comes from the block before it, hence we have multiple blocks. Now, what's so funny, if you go to a website like blockchain.info, and if you look into it, you can actually see all the blocks from the minute Bitcoin started all the way to now. You can do that, actually. And you can see every transaction that belongs to every block. So it's an open system. You can look into it. You can Go through it. You don't have to wait for somebody else to tell you and just get you that speculation that this is true. And you just do that on and on and on and on. Every time you verify a block, you go ahead and you try, because this is basically a race. Everyone wants to make money, as much as possible, as soon as possible. So this is why it's keeping the system fair. Okay. It's fair to say that the longer your chain is, the better it is, because this shows you that a lot of people have done computational power to verify a specific block. In this case, a block 16, has maturity of, it basically has, so all of these blocks that superseded, this actually proves that P16 comes in as the result of so much work that has been done in the past. So when you have, let's say, discrepancy of some sort, a hacker comes in and they try to lie to the system by saying, this is the right block. And if it tries to, circulate this news, it won't be able to happen, because when you have a lot of people working in this system and they have the ledger from the ground up, they'll be able to build as faster, because it is, you have a better computational power that you can rely on. So rule of thumb, when you find a longer chain, whenever this happens, by the way, all of this is being handled by the Bitcoin protocol under the hood. Yeah, so you don't need to understand it fully if you're not interested, but just think about that. The longer chain, like the longer chain it becomes, the more secure the system is basically. And so in general, so we can close this mining chapter, remember the mining is an imperative and a rewarding race just to keep the Bitcoin ecosystem secure and fair. When you have everyone trying to fight to make sure that they monetize it from the system, it becomes much more difficult for hackers to break into the system. And that's why a lot of people now do a crazy work trying to make money. And you have, basically garages, you have warehouses, dedicated for just mining Bitcoin. And it's making it honestly, much better in terms of, being fair, to be quite honest. Now, many nations find Bitcoin as a, beacon to exist. A beacon. This was actually written wrong, but what I'm trying to say here, the Bitcoin system is a great alternative for a lot of nations that don't have a lot of trust in USD. A good example, what happens in China and Latin America. And Latin America is actually funny, because some of those fiat currencies are so fluctuating, they fluctuate so much that sometimes the Bitcoin currency itself is much more stable than those fiat currencies. So think about that for a second. Yeah. And this computational work that we talked about, by the way, is what we call the proof of work. And the proof of work really shows that you've done your hard work of figuring out, that secret number by doing a lot of computation. Now, a lot of people have different ideas on the computation. Some people are not happy about it because it takes a lot of electricity, which is true. Hence, Bitcoin mining is not free. You're actually spending electricity in return for that cash. So it has to be worthwhile if you want to be, in that space. So, and for example, in the Gulf, electricity is not so expensive compared to other countries. And so it might be profitable for us, maybe until now. These things can change going forward. But the idea is it is very cheap in some places, and in some other places it can be extremely expensive. So the mining aspect wouldn't be really that profitable to begin with. Now, a proof of work is one consensus algorithm, and we call it consensus because everyone has to agree on this algorithm in order to figure out the right number. But there are other consensus algorithms out there. We have proof of stake, and we have some other cool stuff out there. And the idea is when you have other consensus algorithms, you're trying to do things differently. So with proof of work, everyone has to do this computational work in order to make sure that they have, the secret number, and then somebody gets the reward. But as you can probably see, this is just too consuming in terms of the power and the time. And so other consensus algorithms are trying to fix it by having different methodologies. So proof of stake, for example, is trying to randomly elect people from the system and give them the final verdict of saying, okay, what is true, what is bad, what is the correct truth, let's say, about the system and the state of the system. A lot of people have their own thoughts on pros and cons and other on all of these other consensus algorithms. However, until now, a proof of work stands to be the best and the most, let's say, stable on proof, like the proof, the most, let's say, okay, let me just figure out the right word for it. The most reliable consensus algorithm ever. This is why everyone just talks about Bitcoin as, that, rigid system that doesn't allow anybody to play, around. The difficulty, as we said, changes. So when you have other people joining in, when the power changes, automatically the Bitcoin system changes its difficulty to keep the whole thing fair. Your hashing power, how much you can dedicate for the computation, defines your chances and your monetization basically of the system. This is why we have ASICs, as we said. Now, speaking of pools, by the way, so there are really big pools out there, and these are some of the biggest pools out there, as you can probably tell. Yeah. So this also brings a question. So when we have pools, does that mean it's even good for us? A lot of people really have different ideas, because basically when you have pools now, when a pool becomes so big, just like the BTC.com pool, it might get to that stage when it can just overload the system and it can just basically control the system. And we're going to get to that attack. It's called the 51% attack, which means when you have a lot of people controlling the system, they're all under a single pool, they will be able to exert pressure to other people, and it can just you can just say, and you can basically do whatever you want. So there's no purpose, there's no goal behind decentralization if there's one big pool that can control the whole thing. So this is basically one of the ideas that a lot of people are not happy about, but this is where we are right now, and the BTC pool is still not there. It did not still hit the 51%. A few things to understand about Bitcoin. It unlocks new Bitcoin every 10 minutes. You have 21 million Bitcoin, just like what we said. It finishes around 2140, and the reward decreases with time. So it gets halved, across every 4 years almost. So there was a time where it was 12.5 Bitcoins, and then we're getting to the 6.25, and it gets halved across the year. So the first Genesis block allowed the person who mined it to get 50 Bitcoins in the beginning. So this sort of notion shows you that there's a specific time where this thing is going to just finish, and it's not going to be monetizing enough for other people to start mining. So the Bitcoin ecosystem has to figure out a place to make money through other mediums. A good thing is maybe they can rely on the idea of interest, and interest actually exists within the Bitcoin system. However, there's a lot of talk about it. Not everyone is on board on the bandwagon thinking that they can do, they can monetize as well with interest. So it's still a lot of room, think about it. So if you're a miner, the two elements that you need to get to that thing, to get to the to be a winner, you need to put a lot of effort, put a lot of computational power. Sometimes you cannot afford it. And now you know why people try to hack. A lot of people trying to get access to their machines in order to use them as a computational workhorse to get money. And the second thing is you need to have luck in order to get to that number, to that secret number before everybody else. So there you have it. And because the blockchain is too long and it gets, more transactions are embedded as blocks in the chain, there is no concept of net worth. So you can't tell that this person has this amount in their account, in their wallet. You have to calculate it on your own, because when you have the full ledger, you have the full transactional list. It's just a matter of doing the lump sum for all the transactions for a specific person, and then you can really tell how much they have in terms of money in their wallet. So you have to do that sort of calculation, because we're trying to minimize the amount of data we keep on the blockchain as much as possible. So yeah, just to conclude with the Bitcoin thing here, your keys are going to be your responsibility, nobody else's. When you generate a new wallet, it is your job to keep backups, to make sure that nobody steals your keys. Make sure you put a password on it. Make sure you use a hardware token for it. It is only your responsibility, nobody else. And the 51% attack, just like what I mentioned earlier on, I really urge you guys to read about it, because this is one of the theoretical attacks that can happen on Bitcoin. So we're not there yet, but this can happen. Okay, so this is pretty much it for Bitcoin. Let's talk about Ethereum, and then we just tackle a few things before we call it a day. So Ethereum is a spin-off to this idea behind blockchain, and it actually got out after Bitcoin. Now with Bitcoin, what happens is Bitcoin is a financial application living in on this foundational layer that we call a blockchain. So if you want to have the difference, here it is. Bitcoin is not the same as a blockchain. Bitcoin is only a financial application that really relies on this foundational work that we just depicted here that we call blockchain. The idea behind blocks, telling each other and all. Now Ethereum, which is an open source project, figured out that they can do the same thing, but instead of having it as a financial application, they're going to have it as a single computer, a single global singleton computer that lives in every machine. Yeah, and so you can have let's say, one shared state across all the machines that have Ethereum. This really helps us by building basically a program. And the idea is you can build the programs that run on the blockchain, and these programs were called smart contracts. So the essential idea is you have programs written in a specific language, notably Solidity, which is a language that is very similar to JavaScript, and you can write rules and such, and you can just deploy it on the blockchain. When you deploy it on Ethereum blockchain, nobody has the power to change that specific smart contract. This changes, again, the dynamics of the game. So you don't have people forcing you and changing the content of blockchain going forward. Because remember, the blockchain is immutable. Nobody can change whatever happens on the blockchain. Yeah. So having code that does not change is also very useful in some cases, especially when you want to buy, you want to sell real estate, for example. And this happens all the time. And we have multiple projects in the Middle East that rely on this idea here. Because the funny thing is, computers never lie like humans. Yeah. And so sometimes it's really fair to say that I want to keep my programs on the blockchain instead of keeping them in a server that can be manipulated by other people or humans. So this is just a sample code that I picked up from Ethereum's documentation. And as you can see, the code is very similar to JavaScript. It's not so difficult to read. If you have any experience with C, C++, Java, or JavaScript, you'll be able to read the syntax in a bit. There are a few concepts that you have to get on, like contract and whatever it is that you have in here, but it's not so difficult to pick it up. And this is the essence of the idea. And so with Ethereum coming on board now, we have so many applications, things spanning the health field. By now you can actually get your data, keep it encrypted on the blockchain, and you can monetize by sharing some of your data when people pay for it. And this never happened. And the beautiful thing about that, you can really tell for sure that the data on the blockchain is only encrypted using your keys, nobody else's. So technically speaking, nobody can just breaking into a server, get your keys outside. This never happens now. And there are literally tons of applications that rely on this idea. Finance, tons of applications. Bitcoin is the biggest by far. Supply chain management also, which is a pretty big deal. See, the managing deal also relies on this idea for manufacturing. Governments now are trying to issue a lot of stuff spanning the blockchain field. Not sure if they really did a great deal in it, but nonetheless, there's a huge governmental effort that tries to maximize the potential of the blockchain. But this, in theory, to be quite honest, goes against their principles, because with governments, you normally want to exert control. With blockchain and decentralization, you want to take that control and give it to power to other people, to the masses out there. So in principle, they don't really go hand in hand. And so this is why you don't see a lot of government applications using blockchain. And so let me just put a few notable mentions before we close. So there's this concept of ICO. If you ever started a business, you know that this concept IPO, initial public offering, is an exercise you do when you open up to the public, so you can start getting capital from people when they buy shares from your company. Now, this exercise takes a lot of time. It's very complicated from a legal perspective and all. And it is complicated for a reason, because you want to make sure that the companies that are opening up to the public are actually legit. Companies like Pluralsight, other companies like Tesla and such. Now, there's another concept called ICO, which stands for initial coin offering. And it's almost the same concept, but the fact is you do that sort of, capital gain by allowing people to buy tokens of from your blockchain or your cryptocurrency, basically. So it's a way to allow people to gain share, and you gaining either fiat currency or some other coins in order to raise capital to build a project or pay people. So this is now a new way of getting funding, but it's being regulated as we speak. The SEC in the US, the Securities and Exchange Committee, if I'm not mistaken, is exerting a lot of pressure in order to regulate those stuff, because it allows people to do crazy stuff. And you probably heard about some really bad stories happening in the Bitcoin environment, in the cryptocurrency environment, ecosystems where people say this is the next crypto, everyone goes crazy, they buy, and then people vanish and you're left basically dust. Namecoin is a project that tries to decentralize the idea behind DNS. Breaking news, in case you did not know, the domain name system is not really that decentralized. After all, there are 13 main servers across the world, and DNS is not so decentralized after all. Just think about that. So Namecoin tries to rely on the idea behind Bitcoin, behind blockchain, to really make it decentralized. Also, there's a cool project that I really like. It's called Blockstack, and it now got renamed to Stacks. And this is a very cool project. I'm not going to do justice now for it, but what I'm trying to say, this Blockstack project allows you to save your data, away from cloud providers like Facebook and those vendors, this big, social networks and big companies, and you can encrypt those data bits of yours, and then because you rely on the blockchain, you can issue keys for services to rely and access your data. So imagine you don't want to have service A to access your data, you can just block them from your place, and you can really tell that this happens because the data does not reside in the vendor side. So a good example was Facebook. Facebook now has all of your data if you use it, and you're just a user for it. But tomorrow, if you delete your account, do you really think these guys are going to delete your account? This is actually part of the GDPR directives. I don't know if they actually do it now, but nonetheless, having the data at their premise, and in their systems does not mean that you have control over it. With Blockstack, you can actually have that data on your side, and it just encrypts it and decrypts it, using the keys that you issue to these services. So this changes the dynamics of the game. Again, you own the data physically, and you can save it on your machine or on other class of providers like AWS, Azure, and such, and you can, basically encrypt it and get ephemeral temporary keys to other services to decrypt it and use it. And this is beautiful because this means going forward, we're going to allow people to monetize from their data if they want to, which is beautiful, in my humble opinion. There are services like IPFS, Interplanetary File System, Filecoin, really great ideas that are on top of the blockchain, ecosystem. And my favorite by far is when we get to that stage where we can have a decentralized identity. Your identity is decentralized. You don't have to belong to a specific country, have to belong to a specific government to do your work. So with Blockstack, for example, this is my ID, Ameen.id, and this shows everyone else in a decentralized format that this is Ameen Altajer, and you can verify his details because I own the keys to the stuff that you see here. And this is powerful because even though it says core.blockstack.org, you don't really have to rely on Blockstack to run it because this works in a decentralized format, just like in a peer-to-peer fashion, just like what we said. You don't have to go ahead, and rely on the Blockstack website. If it's down, you can go somewhere else and still verify my identity. So just think about the opportunities that can spin, and come up, when we have that sort of thing coming in. So to conclude with this chapter, censorship is going to have a very hard time, and a very rough time keeping up with the blockchain, because with blockchain, you don't have a central authority where you manage stuff. It's a state of mind, it's the tools and those infrastructure bits that are allowing us to do a lot of work, be it computation, financial system, in a decentralized fashion with no control for the middleman. So this is my 2 cents for, basically the notable mentions. Let me conclude my last chapter with investments. It's just a 2-minute talk. I'm not going to take much. But this is the question you've been asking about all day, I'm guessing. So just remember that Bitcoin is a currency. It was not meant to be traded, just like what we see so far, where people just try to hold, they call it hodl. They hold Bitcoin and they wait for it to rise up, and then they sell and they just treat it, as a basically a commodity. It was not meant to be treated that way. It's a currency. So don't think about it in a bad way when you see people going crazy about it. This is their perception of it. This is the way they use it. But when you go inside the Bitcoin ecosystem, it was meant to be, it was meant to transact with other, it was meant for you to transact with other parties in Bitcoin. But because it fluctuates so much, people are using it to make monetization gains, basically. And in case you wanted to get to it, it's a game of supply and demand. When people go crazy on it, the price is going to go up. When people ditch it, it's going to go down. And this is very, heavily dependent on the news, basically. And so when you hear bubble and bubble, think about the technology, think about it, like what it tries to achieve. Don't care about the investment that much if you're not really an investment guru, if you don't care about it, because the tech can really open up a lot of doors for us. And then again, it's a big game. It's a calculated guess if you want to do the investment. You just calculated if you want to go. But my last advice to you guys, if you ever wanted to invest, don't put all of your eggs in one basket. If something breaks, you're going to be done for the day. Yeah? So I'm sure you guys have a lot of people interested in investment. My last takeaway here with Bitcoin and blockchain, Bitcoin is not just a currency. It's a true and a practical shift in the way we apply decentralized trust, where systems can just trust themselves and trust each other without having a middleman in between. So when you hear Bitcoin has a lot of issues and such, don't really mind it that much, because it is the number one proof of concept that paved the way for all of us to create cool projects that decentralizes, trust for all of us. The future, in my opinion, is going to be beautiful and better. I hope you really enjoyed my session. If you're interested in reading about Bitcoin more, I really advise you to read about the technicality behind Bitcoin and mastering Bitcoin. This is a great book by Andreas Antonopoulos. It's really a wonderful book. This guy is a god when it comes to blockchain. He can explain it really, really well from a technology and a technical perspective as well. You can think about it. This is a very generic book also, which is good. My favorite also by Andreas Antonopoulos is The Internet of Money, when he talks about the practical use cases to great extent, to great length. And then, you can really see where this can go. It's not just money. It's just basically the new infrastructure of the internet. It's just like for us, the new push of the internet. It just takes it to a great deal. If you're interested in seeing my other talks, especially on Google, you can check out Ameen Altajer on YouTube. There's a lot of stuff on reverse engineering, open banking, and such. Last but not least, I hope you guys enjoyed it. I'm going to open for questions, but you can always reach me out through those mediums. Thank you so much for listening to me and hearing what I have to say today.
And with one word, literally wow. Like that energy since the beginning, like
Thanks, man.
insane, seriously. Like
Thanks. Appreciate it.
So
personally, I have two questions
Go for it.
about this technology. And I want to talk about the exchange companies. You have covered these exchange companies like Coinbase and Binance very fastly. And I'll be asking about these companies and connect this topic to regulations.
Yes, please.
Is there any way to take an advantage of knowing any instructions before anyone else? Of course, by these exchange companies, like they can be able to know the instructions, the transactions before everyone else. So are they using this advantage for anything?
like abusing?
When you say transactions, you mean do they have different source for knowing which transactions are going to happen?
I mean just I'm investing any cryptocurrency,
Okay.
and they get these instructions. So Berkay is investing Bitcoin or Ethereum, and they know these instructions before everyone else.
Yeah, gotcha. So this can, give them the advantage of being the middleman again, because you're in the middle and a lot of people transact. You have that data. You can see that there's a huge amount of, demand being done to a specific cryptocurrency, for example. And if you have, let's say, machine learning, if you really want to go crazy with it, if you have proper prediction models, you can really tell that, okay, this is going to boom in the next, let's say, 1 month or so. So you can get more reserve from that specific fund. A good example now, maybe Bitcoin is too late for Bitcoin now because everyone knows about it. But for small cryptocurrencies out there with machine learning, maybe you can tell, I can see a pattern in the way people are, buying specific things, especially again, when you are integrated with machine learning and you say, you know what, let me buy a lot so I can have that advantage going forward. Now, maybe it's not an exchange, but another trivia for your story is a cryptocurrency, supposedly cryptocurrency called Ripple, if you heard about Ripple before. Now, Ripple is not really a decentralized currency. It's actually centralized, but sugar-coated as a decentralized way. And it's made its way through governments and central banks because, it wants to be there. And with Ripple Labs, the company that created Ripple, they actually have a lot of XRP stored, under their hood, not being out there. So they have this not fair advantage, let's say. So when things break down, things go crazy, they have already a huge funds in circulation that they can rely and have an advantage. The guy who actually made Ripple is now a billionaire because of that. Yeah. So yeah, maybe in that angle, yes.
And my second question is about the regulations, but there was happened a biggest fraud in Turkey about cryptocurrencies, like maybe whether you heard or not, TODEX.
Yes.
And the Turkish government has prevented to exchange by cryptocurrencies any exchange by crypto assets. Yes. So what do you think about these prevention, and is it enough, or what they should do?
Okay, so this is the hard truth, to be quite honest. A lot of people believe that when you block an exchange, you kill the Bitcoin ecosystem. It doesn't work that way. It's just like peer-to-peer. If you take down a specific tracker that has multiple files in BitTorrent, it's just you finding another tracker. Yes? Finding other peers that can supply with the data. It's the same concept. So with Bitcoin, you don't have to transact over the network to begin with. You don't have to do it over the internet. You can give somebody over the phone, for example, your public key, or in this case, your address, and you can do it and you can sync somewhere else if you want to. So in general, governments, and this is the hard truth, and they take it with a grain of salt, they can't block it. They know that, but they try to block it from the masses out there. For the generic people interested in investments and such. But if you want to go crazy, you can transact under the hood. You can do it in black markets. There's no stopping for that. And this is why governments figured out that they can maybe regulate it to a great extent, like the CBB, the Central Bank of Bahrain, to showcase to people and businesses that here we are very progressive when it comes to technology and such. We're not going to block you, but when it's so bad, we're going to block it. And so with what happened in Turkey, for example, this is a very traditional case, in my opinion. Because when people do it in exchanges, somehow when the exchange owns your keys for basically your wallet, you're giving basically your full your full trust to them to manage it. And the exchange itself has what they call a hot wallet where they do their cash basically and funds and everything. But because you have everything in their hands, there's nothing stopping them from shutting down the whole machine, taking everything, and there is nothing connecting them to the wallets later on. They can spend the money and nobody would know. And with projects like Monero, you can actually spend the money and make it much more difficult for people to track your cash. And so my suggestion, if people are interested, do not have, let's say, wallets embedded within those exchanges. Have them on your machine, manage them in your token, let them send the cash instantaneously, and that's it. Don't allow them to control it.
Thank you very much.
My pleasure. Okay, SHA-256 produce 64 characters every time. Do you think it's possible to compress large data? It's possible to compress large files. This is actually, so SHA-256 is not a compression algorithm. It's a hashing algorithm, which means you get a signature of the data that you push in. In SHA-256 is being used And if I'm not mistaken, SHA-50. So the more you have bits, the better it is. But the more time you're gonna have to take to do it. Normally, we use it all the time to check a signature of something, and it goes hand in hand with digital signatures in your private key when you want to sign something. But if you look into Bitcoin, we actually do the SHA algorithm twice on certain stuff just to make sure that we don't have other vulnerabilities. But if I understood your question, yes, it can be used in a plethora of ways, but it's not used for compression. It is used to verify the signature of something. So imagine I give you an ISO file, and I tell you this is a version of Linux that I did myself. If I give you the signature in another medium, in an email or something else, you'll be able to verify that, okay, when I downloaded that ISO image, that 4 GB worth of data, it is really coming from Ameen. Nobody tampered with it. It's the same concept with Bitcoin. What do you think of smart contracts in terms of security process? I like smart contracts, but it's like a time-ticking bomb. So when you push a contract out there, you have little to no control over it unless you really build it in a way to accept changes going forward. A good example for you guys is a case that happened on Ethereum that goes by the name of DAO. Read about the DAO, D-A-W, D-A-O, which means I think distributed autonomous organization, if I'm not mistaken. But there was a bug in a smart contract that they pushed out there, and Ethereum the DAO was acting like a bank. It has a lot of money. It had a lot of money. So somebody abused that smart contract, just like figuring out a vulnerability in the system, just like the earlier session. And they managed to get a lot of cash. Somebody just got a lot of cash. He figured out this. Now the community figured out, okay, so we really screwed up on that program, and we lost a lot of money. How do we go about solving it? Do we, revert back? Do we all agree on forking and basically changing the track of history? It's like going back in time. But this defies the idea of blockchain. It's supposed to be immutable. Nobody has to have power over it. How come the Ethereum folks now, are going to go back and change how history works? But at the same time, so again, just read about the DAO. Very interesting topic. There's a lot of it. I think if Bitcoin or other crypto money did not exist, deep web, dark web was not going to be bigger. Extremely true. Extremely true. What is so funny now, Yunus, exactly, is that a lot of people now, they created business models on top of the dark web combined with that thing. So for example, I'm not sure if you know this, but in ransomware, some people tell you that, if you infect your company, if you work in a big bank and you infect a company, we're going to give you a small margin of the money we make, from the ransomware. So this is, to me, extremely funny because, there's no honor among thieves, but somehow they have business models in order for people to infect their people and give money. Yeah, so there's a lot to it. I'm not sure if you guys want to hear more, but I completely into it. I love the subject, and I can talk for hours.
I've definitely should continue anytime soon. Actually,
sure.
The topic is too big to include in just a few hours. So I don't think that we have to extend the sessions also in the upcoming events.
Sure thing.
Or I don't actually see any questions, I think, anymore. So then I'd like to actually thank so much. Exact for actually the accepting our invitation.
My pleasure.
Being a part of this event, it's just amazing. Actually, so
yes,
since the beginning, actually,
yeah.
Keeping the energy, keeping the content very the educational at the same time. It's very good, actually. We just love it in the background. We're also in the backstage just watching. Literally amazing.
Thank you, Berkay and Busal, and thank the team for me, please, because you guys are doing an amazing job. Thank you so much for doing this platform, and I have a lot of fun, and I'm going to see you next time for sure.
All right. See you then.
See you guys. Take care.
Bye-bye.
Have a great day. Bye-bye.